Hello, this is Mr. White, and this video is on sketching a function with given conditions. Over the years, I found that students tend to struggle with this question at first, or this type of question, but then once they get the hang of it and they see how to approach it, they realize it's really not that bad. So our task here in example 1 is to sketch freehand a graph of a function f that satisfies all of the following conditions. And the implication of being asked to sketch it freehand is that we're not going to worry about what equation generates this graph. We're not going to worry about the algebraic model. We're only thinking of the graphical model here. So we are to sketch a graph that is even, symmetric across the y-axis. I see something here that could be mistaken for point coordinates, could be mistaken for x and y coordinates, except that we're told that it's increasing, and so we know that this must be an interval. So those are not x, y coordinates. That's an interval from x equals 0 to x equals 2. The graph is increasing. And then it decreases from x equals 2 all the way as x approaches infinity. F of 2 equals 3. That's basically giving me that's what's giving me an x and a y value. We are then told that the y-axis is also a vertical asymptote. The x-axis is a horizontal asymptote. Okay, so it's a lot of information, and I think the key is to just decide an intelligent order to tackle these clues in. So there is no one right answer here, but I would recommend that if you're given a point, such as we are in clue C here, if you're given point coordinates, go ahead and graph that, because as long as you do it correctly, there's really no need to second guess it. Whereas, for example, if I jumped right into drawing some even function, I may draw an even function, but I may then find that I have to revise it later because it violates one of these other rules. So let's go ahead and do clue C there. F of 2 equals 3. So 2 over 3 up. And as long as I'm doing that, I really should label my axes, at least put a few numbers on there to give a sense of scale. So I'll put 3 here. And that's the minimum amount I ought to label as far as axes go. So there, I've satisfied condition C. I then typically like to follow up by looking at the asymptotes and sketching those in there. So we're told that the axes serve as vertical and horizontal asymptotes. And even though the axes are already drawn on there for me, I just like to emphasize with a dashed line. I always like to draw asymptotes with a dashed line, and I'll go ahead and sketch that in here just to remind myself visually that I have to honor those asymptotes. Okay, since this is an even function, I'm not going to try to launch right into the entire even function, but I will observe that this point has to be reflected across the y-axis. So due to the fact that it's an even function, I combine clues A and C, and I know that I have a point over here at -2, +3 as well. All right, let's look at clue B now. Again, I'm always keeping in the back of my mind clue A, that's an even function. But I'm told that it is increasing, this function is increasing on the interval from 0 to 2. So I really focus in on that interval, on all the x values between 0 and 2. And I'm walling that in here for you visually. And I need the graph to increase over that interval. But remember, it doesn't have to be at 0 to 2. We didn't have brackets there. I know I've hidden that a little bit. But we didn't have brackets here, and I'm not implying that it actually has to touch 0. So I can satisfy that condition by drawing something that is asymptotic to the y-axis and goes up like this. Okay, not the perfect picture, but you get the idea. It's clear that I'm trying to draw an asymptote there. Okay, so I would say that satisfies the condition, increasing from 0 to 2. Let me get these out of the way. And again, keeping in the back of my mind that this is an even function, anytime I draw something on one side of the graph, I'll draw its mirror image across the y-axis to keep it even. Okay, we now have the graph decreasing from 2 to infinity. So again, I'm really focusing just on this part of the graph. From that point on to the right, this graph needs to be decreasing. But remember, I can't just do something like this because I have to respect the asymptote, right? So let's draw something that is decreasing from 2 to infinity. And when you draw an asymptote like this, it is technically decreasing as long as it keeps approaching the x-axis. And there we have it. So once again, it's an even function, so I'll draw the mirror image. something like this. I'll step back and I'll look and make sure that I've honored all of the clues. It is an even function. It is increasing from 0 to 2 and decreasing from 2 to infinity. It did go through the point 2, 3, and I did get asymptotes along both axes. Okay, so we are done with that one. Let's go on to the second example. Okay, same instructions. We have 5 new clues here. We need an odd function that is constant on this interval from 0 to 5, x equals 0 to x equals 5. Again, I emphasize, don't confuse that with xy coordinates. The context clues tell us otherwise. Here's where we have an x and a y value at 4 and negative 2 respectively. We're given a vertical asymptote, and we're told an interval along which the function decreases. So I'd ask you to consider, which clue would you start with? Again, there's no single right answer, but I would tend to start with a point. F of 4 equals negative 2, so I'll go over 4, down 2, and again, I'll label the axes, at least put a number along each axis to give me a sense of scale. In this case, I'll keep in the back of my mind that f is an odd function, so in this case, I'll do another point at negative 4, positive 2. Okay? Let's see, I like to do the asymptotes next, right? So let's draw a vertical asymptote at x equals 6. So I'll go over to x equals 6. And once again, since this is an odd function, I would expect to have an asymptote over here at x equals negative 6 as well. Now you may be thinking, isn't that what I would do in the case of an even function? Yes, but also for odd. Just remember, if it's asymptotic over here, it would be asymptotic down here, not across the y-axis. All right, so we have drawn in the asymptotes. Let's see, what should we do next? Let's do that clue B. F is constant on 0 to 5. Again, reminding ourselves that that is an interval. Let's really focus on the window between 0 and 5. And I need the graph to be constant there. There are literally infinitely many ways I could draw a constant graph there. I could do something like this, but there's a couple problems there. Let's tackle what perhaps is the most obvious problem here, is that I now have something that is not a function. It doesn't pass the vertical line test. So in order to honor clue C, but still implement clue B there, that it's constant, I need to make sure that it's constant down here. Okay, so that addresses the most glaring problem. I really have no choice but to make sure that it's constant here at a y value of negative 2. And the other problem comes when I try to honor the symmetry of this graph. When I say, okay, if it's constant from 0 to 5, then I must have something over here as well. But notice here we also have once again violated the vertical line test right along the y-axis. It goes through 2 points. So remember that it's constant from open interval 0 to 5. And so I'm going to fix that simply by turning those closed points into open points. And now I no longer have a conflict. I no longer violate the vertical line test. So I've got clue B implemented there. It's still an odd function. And the last clue I really need to focus on is that f is decreasing from negative infinity to negative 6. I really focus on that part of the graph. And if it's decreasing, I really don't have any other clues that are going to dictate what goes on in this region. So I could have the graph do something like this. It could be way up here. It could be, could be way down here. There's really, as long as it's decreasing, it doesn't really matter where I draw it. So I'll just leave it like that. And if I leave it like that, then I just need to make sure it's still symmetric. So it must also be decreasing from 6 to positive infinity, something like that. All right, and I could call it done at this point, I believe. It is an odd function. I do have an odd function. It is constant from 0 to 5, x values. It does go through the point 4, negative 2. It does have a vertical asymptote at x equals 6, and it does decrease from negative infinity to negative 6. I could call it done. Just as far as other options you have, if you're wondering, doesn't it have to be asymptotic over on both sides of the asymptote, something like that? It can be, but it doesn't have to be. I could draw those asymptotes in there. It doesn't violate any other rules, but as long as it's asymptotic on one side of the asymptote, as long as it's approaching the line on at least one side, it doesn't have to approach the line on both sides. If I wanted to, I could also make it asymptotic in this way, as long as I make sure it maintains its odd symmetry, okay? But I'm going to go back to what I originally had and say that was good enough. I hope that made sense and gave you a little insight. Let's have you give it a shot. Here is your turn. You know the drill. Pause the video and give it a shot. All right, I'm going to assume that you've done your part, and let me bring my solution up here, but I emphasize there are other ways this could have been done. So I'll leave you to decide. If your graph doesn't look really a lot like this one, I'll leave you to decide whether your graph is also an acceptable solution. And of course, if you have any questions on it, please come on by office hours.